Okay, this is section 3.6, factoring sums and differences of cubes. First things we need to know is our patterns. The first one is the a cubed plus b cubed pattern, and that expands into a plus b times a squared minus ab plus b squared. These are set formulas. So if it's a sum in the middle, then you're going to follow this one. If it is a minus, which is difference, it's a cubed minus b cubed. And the pattern becomes a minus b, a squared. Now, instead of a minus ab, it's going to become an a plus b squared. The only difference is the sign in the middle has been swapped between the positive, the sum, and the difference. So when you look at this problem, it says z cubed plus 8, which means the sum cube. In order to break it down, first thing we do, we need to format it into powers of 3. So you take your original problem, z cubed plus 8, and rewrite it to say something to the power of 3 plus something to the power of 3. The power of 3, z, if I raise z to the power of 3, I become z cubed. If I raise the number 2 to the power of 3, I become 8. And if we look here, this piece right here, this represents the A position and this represents the B position. Because we've identified our A and B, all you're going to do is take your equation, that's the sum one, I'm going to write it down. The expansion says it is A plus B, A squared minus AB plus B squared. And we're going to use substitution and replace our parts. So A plus B, Z plus 2. Then it says A squared. Well, Z is the A. If I square it, it becomes Z squared. Minus sign, it's A times B. A is Z, B is 2, so you're going to write 2Z. B squared, well, 2 and you square, you become a 4, and you are finished. So our answer is Z plus 2, Z squared minus 2Z plus 4. On the next one, again, it is a sum cube. We're going to apply the same situation. You can take your problem, 216z cubed plus 125. Parentheses power of 3, parentheses power of 3. Cubes. Remember your cube pattern. So if I take the number 2 and cube it 3 times, I get an 8. 3 cubed 3 times. It's 27. 4 gets you to 64. A 5. It's 125. And then a 6 is your 216, which is the number we need for here. So a number that's multiplied 3 times, it gives you 216 is a number 6. And then I'm going to put a z because it's a z cubed. A number multiplied 3 times, it gives you 125 is a 5. So now this inside is the a, this is the b. Remember, it's a cube, sum. So it's the a plus b, a squared minus ab plus b squared situation. We are going to replace, again, by substitution, our a and b. So a is 6z, b is a 5. A squared, well, 6 squared is 36. We have 36, and then our z squared, because it's z power of 2. Minus sign, it's a and b multiplied. So 6 times 5 is 30 with a z, 30z. And then b squared, 5 squared is a 25. So our final answer is 6z plus 5, 36z squared minus 30z plus 25. Make sure that these cannot be factored down. You want to think of factoring as being the perfect square trinomials, but normally you would think that you can factor this out. Yes, the square root of 36 is 6 and square root of 25 is 5. Which gives us 30, but you have to double that to be a 60 if this was to break down to a perfect trinomial. Moving on to our next example. So in this problem, it says 5x cubed minus 135. So when we look at this problem, there is no number that multiplies 3 times in a row that gives you 5, and there's no number that multiplies 3 times in a row that gives you 135. So for this problem, the first thing we need to pull out is a GCF. So 5x cubed minus 135. Since this ends in 5, it means they're both divisible by 5, which means 5 factors out. So you get 5 on the outside, x cubed minus 27 on the inside. So remember, now this is a difference one. So The a cubed minus b cubed situation is a minus b, a squared plus ab plus b squared. So the 5 is isolated to the outside. We know that's there. We need to figure this situation out. So I'm going to have 5. I'm going to use a bracket to take the difference pieces. So I can put parentheses power of 3 minus parentheses power of 3. So a number multiplied 3 times in a row that gives us x is still x cubed. A number that gives us 27 based off the previous ones is a 3. So we've identified our a and our b. The 5 does not go away, just slides down. So if we're looking at our situation of a minus b, x minus 3. It says a squared, so x squared. Plus, it says a times b, well, x and 3 is still 3x. Plus b squared, well, 3 squared is a 9, and we're finished. So this is what it factors out to be. On our last example, it says factor completely, again, using sum or differences. So we look at our problem, it says 64h to the 4th minus 27h. So yes, 64 is perfect cube, 27 is a perfect cube, but the difference is this is not a power of 3 for the h. So again, we need to pull out our GCF first. So 64h to the 4th minus 27h. We're factoring out an h out of both of them. So it becomes 64h to the 3rd minus 27. I used brackets in this one just to make it easier for us. H comes here. Now I'm number power of 3, parentheses power of 3. From our previous examples, we know that 64 is actually the number 4 3 times with an h. The number 27 is actually the number 3 repeated 3 times. So now we have identified our a and the b. So the same pattern that we did on the last one, the a cubed minus b cubed is a minus b, a squared plus ab plus b squared. So again, the h slides because that was our GCF. It is a minus b. Well, a is a 4h minus the b value, which is a 3. Then it goes a squared. Well, 4 squared is 16 with an h, so 16h squared. Plus sign is a times b. Well, 4 times 3 is 12 with an h. Plus sign b squared. Well, 3 squared makes it a 9. And we are factored out.